implications of that are actually fairly dramatic, because it means that these systems have to have self-organizing properties. Devices have to find each other. The monitoring systems have to find the devices. We have to distinguish the devices they're supposed to monitor from the ones that they aren't, like the ones that are next door. And for some of the communication alternatives, there isn't any guarantee that you won't encounter devices that are not supposed to be a part of your local universe. So figuring out how to do this kind of self-organization in a way which is secure and also maintains privacy and so on is a non-trivial exercise. And some of you are going to be confronted with that because of the various groups that you're working with. This mutual authentication idea, and again, strong authentication notions, appeals to me very much because it's important that we are able to know whether we have a consistent system with devices that recognize each other and recognize their controllers and the like. So on top of which, it would be important to know who is allowed to have access to the information either generated or consumed or held by these devices. So we need to have ways of doing authorization and authentication that protect people's interests. A rather interesting situation is that some of these devices may move from party to party. I mean, you sell things at garage sales, or you shut down industry and people buy things at auction. Having the ability to reset and have the system go through a self-organization is very important. So again, please think about the requirement to do that, because it's not the case that having acquired something, it will be kept by the acquiree or acquirer forever or for the lifetime of that particular device. Then there's this question of data transport, and we had lots and lots of discussions in various parts of this Smart Grid Interoperability Forum about various choices. I think that the IPv6 idea is helpful, if only because it's a well-known protocol and it has lots of address space. We may still need to have some support for IPv4 in order to cope with the fact of, like, the situation I have at home, where I have a V6 6-LoWPAN network that's doing all the monitoring, but right now it's plugged into a system, a network service that only knows about IPv4. And so one of the controllers, the thing where all the data is being accumulated, knows how to talk V6 on the one side to all the sensors and V4 to the other side in order to reach the rest of the internet. At some point, I hope I can reconfigure that so that it's speaking V6 on both sides. The idea of having a common representation for the information that these devices are accumulating is important. One of the groups is working hard on something called SEP, the next version of SEP 2.0. And here, I'm not trying to necessarily argue that that's the only one that we should be considering, but I do want to say that it's important we have a common way of representing the information. In a different context, to go back to the ARPANET world for just a moment, one of the problems we had was that we had all these different host computers whose resources we were supposed to be sharing. They came from different manufacturers, and they had different kinds of terminals. And we didn't want every host computer to have to know about every single kind of terminal on every computer in this ARPANET. So we agreed that we would invent a thing called a network virtual terminal. It didn't exist. It was a figment of our imagination. But the idea was that if an operating system was serving some particular kind of terminal, that it would translate whatever that terminal looked like into this common network virtual terminal expression. And so if you were a server on this network, the only thing you had to worry about was the terminals physically connected to you plus anything that showed up looking like a network virtual terminal. And that removed a lot of the n-squared translation problem that would have been common. So in a similar way, we may need to have ways of expressing a lot of the kinds of information that might be accumulated by these devices, whether it's about electrical power or about any of the other commodities, and express them in a way that everybody is willing to accept, and then, if necessary, translate into maybe some local proprietary representation for purposes of further interaction. regard to monitoring and measurement, there have been debates about whether for example, the meter that might be installed by the power company should have in it also, combined together, an energy management system, or whether that should be a separable thing. I'd like to suggest to you that architecturally we'd like both of these things to work. We'd like it to be possible for someone, a third party, to offer the consumers an energy management system which might be independent of the meter. There's no reason why you shouldn't also have the possibility that the meter comes with a built-in energy management system. The implication of that architecturally is that there's an interface between the thing which is gathering data and the thing which is analyzing the data, and that interface be standardized so that multiple parties can offer these energy management systems and interact with the measurement part of the system in a uniform way. So a lot of these desiderata have implications for the nature of the architecture, the nature of the protocols, and the kinds of interfaces that need to be selected in order to give this kind of competitive flexibility. So there are a lot of ways in which we may interact with this Internet of Things, particularly many of the things that are part of our smart grid world. So I just want to step through and remind you of some of the perhaps unexpected things that might happen. Some devices may have tiny web servers built into them. In fact, I would, having gone through this slide set with someone earlier today, every single one of the examples I've given are not just may. Every one of these actually already exists. So there are devices like printers that are configurable, and you plug them in and they have a little web server on them. The same is true for the sensor network that I have. If you go and connect to its web server on the local internet interface, it pops up a configuration web page for you. So your browser becomes the tool for configuring this thing. Some of the management systems, like the SensorNet I'm using, already have a web-based tool kit for managing. Some of them may actually send email. Certainly the system that sends me the alerts about the wine warming up is doing exactly that, or the moral equivalent of that with SMS. Chat, you may actually have devices that will chat with you. It feels a little odd, but in fact having a chat with your refrigerator might someday make sense, especially if the things inside the refrigerator have RFID chips on them, and you can legitimately ask the refrigerator, do I have any milk in the refrigerator? Now, it might not be able to figure out how much is left. It might only be able to say that it's been in there for 3 weeks and it's going to crawl out on its own if you don't do something about it. So the idea of having an interaction, and by the way, it doesn't just have to be text interactions. There's always the possibility. I can imagine, various devices around the house tweeting at you. This is a weird world that we're in. Or some of them, especially that are mobile, may very well make use of the fact that they know where they are and want to report to you where they are now, or you want them to report to you where they are, or or maybe you want to be able to ask where the hell are you, like your luggage, something. You've heard the story about the guy that goes up to the ticket desk and he says, I'd like to buy a ticket to Paris and I'd like my luggage to go to Istanbul. And the clerk says, ticket agent says, I'm sorry, sir, I can't do that. And he says, well, I don't know why not. You did it last week. So anyway, geographically indexed information is turning out to be immensely powerful and useful. We see it at Google, of course, because of the use that people make of Google Earth and Google Maps.